right, let's continue talking about the atom. We want to get into now what we know from the periodic table. So when you're looking at an element on the periodic table, you're looking at its square, you're given the chemical's name and its symbol. The whole number that you're given represents the atomic number, and the atomic number is the number of protons in the nucleus. It's what identifies the element. Any atom with one proton is a hydrogen atom. Any atom with 6 protons is a carbon atom. So the number of protons, the atomic number, defines what that element is. All right, so if we take an example, if we find lead on the periodic table, its atomic number is 82. That means it has how many protons? 82. Now, if it's a neutral atom, how many electrons will it have? Also 82, because you want the protons and the electrons to equal each other so that there's not an overall positive or negative charge. Now, we could also go the other way. If an element has 8 protons, what element is it? Well, find number 8 on the periodic table. That would be oxygen. So our element here would be oxygen, and our atomic number would also be 8. All right. Okay, now when you have a particular element, all atoms of that element have the same number of protons, but the number of neutrons can differ. And if you have atoms with the same number of protons but different numbers of neutrons, we're going to call those isotopes. And in nature, most elements are found as mixtures of isotopes. So some isotopes are more abundant than others. For example, potassium is almost all potassium 39. Very little is potassium 41, and almost none is potassium 40. Now, when you're looking at this notation right here with a name and a number after it, that number is going to represent what we call the mass number. So the mass number is the sum of the protons and the neutrons in the nucleus. So if we're saying potassium 39, that number right there, that mass number, tells us that there is a total of 39 protons and neutrons. And now we know from the periodic table that potassium has 19 protons. So 19 plus 20, if we add those together, that equals 39. So that's how we get the number of neutrons, is by using the mass number minus the protons to get the neutrons. So potassium 40 still has 19 protons because it's potassium. Now that means it has 21 neutrons. Potassium 41, still 19 protons because it's potassium. That means it has 22 neutrons. So this number after the name right here is the mass number. Okay. Now, when you have an element written in this notation down here, the number on top is the mass number, the number on bottom is the atomic number, and then you use the symbol for the element instead of the name. So potassium 41, K for potassium, 41 on top, and then 19 is the atomic number that goes on the bottom. Okay, we're going to skip the example. And talk about the mass. So we're going to use a unit called the atomic mass unit, or AMU. And 1 AMU is defined as 1/12 the mass of a carbon-12 atom. Carbon-12 was kind of set as the reference atom. So 1 AMU is almost, but not exactly, almost equal to the mass of a proton and a neutron. Okay, not exactly, but almost. So 1 proton and 1 neutron is almost equal to 1 AMU. Now, when we talk about the mass of an atom, The atomic mass takes into consideration all the different isotopes. It's a weighted average of the isotopes of that element. So when you look at the periodic table, the masses that you see for an element aren't whole numbers, they're decimal numbers because they are weighted averages of all the isotopes that are found in nature. For example, there are 2 isotopes of chlorine, and this tells us that one of the isotopes is chlorine 35, the other isotope is chlorine 37. Chlorine 35 has a mass of 34.969 AMU, and it's 75.78% abundant, which means 75% of all of the chlorine atoms found in nature are chlorine 35. The other 24.22% are chlorine 37. So if we want to find the average, weighted average mass of all the chlorine, we're going to multiply the mass of the isotope times its percent, and remember you turn percents into decimals, so this would really be times 0.7578, and then we do the same thing for the other isotope, and then we're going to add those 2 parts together, and this number, if you were to look at chlorine on the periodic table, that is the average atomic mass for chlorine. It comes from the weighted average of the 2 isotopes. Okay, so what I want you to do is pause this video, take a minute, see if you can answer this question, and then we will come back and work it together. Okay, so the first thing that we want to do is we want to figure out the total mass contribution in order to find the atomic mass of the element. So we're going to multiply hold on, go back. Here we go. All right, we are going to multiply the mass times the percent abundance for one isotope, multiply the mass times the percent abundance for the other isotope, and then we're going to take our 2 masses that we get here and here, and we want to add them together here to get this number. Okay, now, which element has a mass that is 6.939 AMU? That would be the element lithium. So you can identify the element based on its average atomic mass.